My name is Michael Holdmann. I'm founder and CEO of Prosaga. Prosaga is a blockchain technology company. Have designed and are building an open, permissionless, trustless chain. Through the process of doing some things, we have run into some understanding or enlightenment about blockchain scaling issues and such. And that's what we're going to talk about here, specifically one of the technologies that have come out of our research and design phases. So in the process of looking at how to scale a blockchain, one of the things that came into account was the fact that we couldn't see a way to truly scale because of the inability to actually move state from between parallel chains, from shard to shard, when they started to come up with the sharding technology. And the things that we found here, and it's a challenge, as we say, in chain code, but the same in smart contracts. They're static, they're not dynamic. Versioning or updating smart contracts or chain code is difficult. We compare it to a smart contract to say every time you want to write a Word document, you have to write the Word application. You basically have to copy a smart contract, paste it into an editor, edit it, and then upload it. So you're re-uploading the program every single time. They're not easily created or updated. It can take, depending on the complexity, yes, you can do a simple smart contract in order to do a transfer of a token from one wallet to another. However, it's when you're starting to get into complex supply chain and such like that, it is not as easily done. It can take multiple FTE years to create and deploy. Code requires reloading for each new contract, and it doesn't have a global repository. So what we have is the eXtensible blockchain object model. Now, a little history about eXtensible blockchain object model. It is, we call it a decentralized global operating system. And the first time we've integrated it with a blockchain is on Hyperledger. We'll go back to where it started from. And that was, it's based on a message passing architecture, which was developed by Xerox Labs, the Park. That's a Palo Alto research. It was the message passing architecture called Smalltalk was introduced in the early 70s. Since then, it's been used as an underlying architecture for the leading global operating systems. You might remember, and we compare a lot smart contracts to an MS-DOS. MS-DOS, where you can run one application at a time. And then the invent or the introduction of Windows. And Windows is a common object model, a class tree. It's a modified version of the first class object model. First class object model was actually also utilized by IBM in a system object model, and another organization called Gold Corporation in their Penpoint OS, which was a tablet-based operating system. The other organization that uses a first-class object model or modified first-class object model would be Mac OS 10. It was used by Steve Jobs when he had Next and started Next OS. So history on what first-class object model is there. Dave Beberman will go further into this. I'm kind of going to do the highlights, and then Dave is going to go into, he's the co-founder and CTO. He's going to go deeper into the actual tech. He's going to show how classes and objects work within Hyperledger, and also do a brief code review or loading that show how it loads into Hyperledger. And what it is basically an object-oriented blockchain. Now, we did have one individual, Casey Tam, who is a Hyperledger instructor. He was gracious enough to take time to do a review of the development environment and testnet that we have set up and available now. It is MVP. This is not production ready yet, but it does allow you to go in and start to use object model, use the XBOM, and test it out on Hyperledger. The interesting thing that this does, and I highlighted it, theoretically, the developer does not care about the blockchain as it is well handled by the infrastructure. So to go into here, the advantages of having an extensible blockchain object model. It makes go-to-market 10x faster, 100x faster. The reason is because everybody is referencing the same exact class or copy of code. You're not rewriting code and each time and uploading it into the contracts. It's fully dynamic. You're instantiating or referencing code from a class tree into your account. It's real-time updates. There's no service interruptions. If somebody sends you a transaction and you do not have the proper code in order to execute that transaction or whichever part of that transaction you're supposed to, then your account will look up the class tree, find the code that's necessary for you to execute that transaction. And if you have all the proper credentials, it will instantiate it into your account on Hyperledger. It creates a repository of reusable code throughout all nodes, and it makes many-to-many relationships feasible on a single chain. And what we mean by this in supply chain, we find that the issue is not when you're at, say, General Motors at the top of the chain, but it's when you're the bolt manufacturer down at the lower in the tree, in your supply chain tree. And what that's going to, what XBOM allows you to do is it doesn't care if it's an IBM blockchain platform, Oracle blockchain platform, SAP, or any others. If you're on AWS, the XBOM just knows that you're a Hyperledger Fabric blockchain. And so it will integrate or implement with that. So what we have developed is a blockchain application framework. On the business side, what this looks at is everything from layer 3, 4, 5, and 6. Layer 5 in this instance is Hyperledger. Is unknown or does not have to be managed at all by the application developer. The application developer always plays up in layer 2, and the applications are just the applications where the user interface will, or where the user interfaces with the blockchain. Applications can cover, whether it be pharmaceuticals, oil and gas, aviation, the list goes on. So what Dave is going to do, and I'm going to turn him over here in a minute or two, is he's going to go deeper into how we're actually integrated into XBOM and go into how we're integrated into the peer nodes. One of the things that we had to make sure when we develop this is that we don't do any changes to the Hyperledger source or any of the other source that's utilized in order to make a successful Hyperledger Fabric network. And the other thing that Dave will do is go through and show you exactly how code loads dynamically. Again, you don't have to add more chain code. You don't ever have to add new channels. You can dynamically add new classes to a class tree. And whenever those classes are necessary or the code within those class objects are necessary, the chain, your account automatically instantiates that class object into your account. So I will go ahead and stop sharing. I will let Dave carry on. If anybody has any questions on this part of it, please do ask. I will be back to talk about finish up the last part after Dave is done.
Good morning. Share screen, pull this up, share, and okay, good morning. Can everybody see my screen? I assume yes. So a couple quick things about the extensible blockchain object model. Another way to think about this is instead of object-oriented programming, an object-oriented blockchain. I'll go into how we do that, but the core piece to recognize is that for any object, in any object-oriented environment, it needs a reference to it. In a programming environment, you have essentially a pointer managed by the programming runtime environment, whether it's everything from C++ to Java to C# to Python to you name the language. Actually, even Golang, even though it doesn't do inheritance, does the same thing. What we recognized is that a interesting part of the blockchain is because it's immutable, you can have completely unique references, object references stored on the blockchain. And we take advantage of that, and you'll see how that makes what's called a first-class object model. And first-class object models go all the way back to Smalltalk, and before that, Smalltalk being the language and the designer, the author of it, who invented the term object-oriented programming. And we're basing that all the way back on that technology, which is all message passing with what's called late dynamic binding or very late dynamic binding. First, a little bit about how we put it onto the Hyperledger Fabric. Technically, we probably could put this on Hyperledger Sawtooth as well, although we started down the path of Fabric first, and we're focused on getting a proof of concept out. On the left, you'll see a traditional, I use the word traditional because that's how Hyperledger Fabric works. I don't mean that as a negative thing, is that this is how it actually works. You launch the blockchain. We actually use the test network from the Fabric samples, and you'll see that later. And then you load chain code, a little redundant, but and then you run on it. And the transactions are sent to the train code, and the chain code interacts with the database in the state database layer, in the blockchain consensus layer, manage that. In our environment, we don't change any of the Hyperledger Fabric code to make this work. The difference is that for us, the chain code layer loads the class manager infrastructure that enables the class manager environment or classes and objects. Above that, you dynamically load class code into your runtime environment. We actually use what's called the external chain code model for Hyperledger Fabric, as opposed to having the Hyperledger Fabric build the source in a Docker for you. It's a part of version 2.0 and beyond. On top of that, we have class application framework in ordinary objects and accounts. Walk through them very quickly. Similarly, so in the standard environment, the first part, your Hyperledger Fabric, is managed by peer nodes and orderers. What you'll see is a test network. We actually just use the simple one. It runs 2 nodes and 1 orderer. The orderer, I believe it's currently doing Raft. I don't remember how it's configured, but it's transparent to us. The chain code layer, you use literally load as a peer. We're using all command line from the peer node command at the moment, but obviously you can send strings as well from an API. The peer node loads the chain code as for an external chain code. You actually send out a tar zip file that's configured appropriately. You can read that in the online tutorial for Hyperledger Fabric. A very important point I think we skipped so far, and this just reminded me, our current implementation, all of the classes are written in the Go programming language, and they're loaded as shared objects, which are known as Golang plugins, and there's a specific command to enable doing that with Go. What's very important here is we're not actually at runtime, we're not actually compiling the code. You're literally loading a pre-compiled code. So, and it only needs to be load once per node when it runs a transaction. Once a class is loaded, it can stay in the environment. So you don't really have an overhead for loading it. Class application framework, I will show you the foundation classes, and we have a diagram of it, and we will just do a very quick command line load to show that. We actually call them the Bootstrap classes. And once they're loaded, you have the ability to create accounts. Accounts can contain ordinary objects and similar. An account is an object instance. Every account has one root object called the account object, and then everything else is considered containment underneath it. So you have a containment tree for each account. We use that model superimposed on top of this environment. That's part of the Bootstrap Classes. It is actually possible to think of other models, but in the blockchain world, accounts are the common construct for everybody. A little bit about what a first class object model means, because it's very, very relevant for how we made this work. In a first class object model, everything are actual objects. They exist at runtime. This means that the class that creates the object, so here's class object, which creates ordinary objects, and a metaclass object makes classes, which make objects, and you have a reference to each one of these. Because the blockchain is completely immutable, it's now rather trivial to make global references to every single object, whether it's a metaclass, a class, or an object. And of course, everybody's inheritable, so you can inherit from a metaclass or a class. You can't inherit from an ordinary object. This is a key thing because it means that once you've established any object or any class or any metaclass, that reference is usable anywhere at any time, with respect to any sort of scoping rules, like if you're not allowed to send a message into somebody else's account, that type of thing. But as far as the reference itself is concerned, it's just another object reference. The basic structure, once you've loaded the class manager infrastructure, loads the root class object. So everything, this is a single inheritance, not a multiple inheritance, although it could be done with multiple inheritance. So it's single inheritance with the ability to create interfaces. The root object is called class object. The class is the root metaclass. In class dictionary maintains a string mapping between names in what we call ledger object IDs. What I mean by that is we create, like I just said, like I just pointed out here, the independent object IDs, which we actually do a chained hash to create using the standard SHA-256 algorithm. In order to map back and forth, we call those ledger object IDs so that you can actually work from strings. As you'll see farther on there, we return the 256 hash as a string of integer numbers. This is what the Bootstrap classes look like. So to enable dynamic loading of new plugins on any node, which you need any class all class implementations are plugins. So when you, if you send a transaction to a node that hasn't seen that object or that class tree yet, it needs to be able to go load it. The class file loader is what's used to go load a new plugin in and then establish that the class is there. Technically the class instance data is on the blockchain already. This is to load the code to run the class. Class XBOM is now the root of all future classes. So just like class objects root for all classes, class XBOM is for everything related to the XBOM environment. Going down the tree just a little bit more, the class XBOM container is what implements the concept of containment parent-child relationship. This is literally a list of children with any child can be another XBOM container or subclass and have more children. This is identical in concept to an actual window tree that you use every day and we're using right now. The only difference, of course, is this is not a user interface. It's just a straight object-oriented containment environment. And of course, the class account, which is a root for accounts, is of type class XBOM container, which means that it can contain objects. And I have a picture of that farther down. On the left side is the part that uses what's known as a standard design pattern called a factory design pattern, which of course we named class factory, not very original. In a class account manager inherits from class factory, which means an instance of class account manager will have the ability to create new objects, and the objects that it would intend to create would be accounts. So you would expect that the class account manager will create instances of class account or a subclass, and that's exactly what happens. A little bit more on the Bootstrap cycle. Once it's created all those classes, and of course, there's a little bit of Bootstrap class file loader loads classes, but you have to actually load class file loader first to be able to load classes. So that piece is actually done manually, and then you could use it to load all the other classes, which we do. We then instantiate two initial objects. The root dictionary, which is an instance of class dictionary to give you a way to have a Bootstrap to find initial ledger object IDs, and the root account, which is what you need to use to be able to send messages to anything. All messages sent to all objects you are meant to, you have to send the message to an account, to the object in the account with the method name that you're calling or message name and the input arguments for it. So you need those two things to get it running, and you'll see that shortly. This is what the whole thing looks like. So at this point, you're ready to actually now create an account. I'm actually going to go do this in a minute. And this is what an account would look like. So here's a root account object. And this, this is the root of an account. I'm using the wrong word, root account. So this is an account object. This could be a subclass. This could be an instance of class account as it shows, or an instance of a subclass of class account. It supports, because again, it inherits from the XBOM container. It is perfectly possible to have any number of objects within that account, and any object that also inherits containment also can be another object. Another child list. It's important to note that it was hard to diagram it correctly, but because the ledger object IDs are not typed, they're all, you can send a message to any object, whether or not the object is of the right type or not. If you send a message that an object doesn't recognize, it will simply return not implemented, means that all lists are heterogeneous lists of objects. This is different than you'll see in most object-oriented environments, which are trying to do that type of type checking at compile time. We don't do that. There is some type checking we do for to make the message passing easier, but at runtime, it's actually possible to send any message to any object. Late dynamic binding has some interesting capabilities that enable a different type of object-oriented programming that you might be used to, for example, if you write in Java code. Here's what a transaction looks like. The database we use, whether it's CouchDB or LevelDB, which is the Hyperledger database. Unfortunately, I'm not familiar with Hyperledger Sawtooth's database, but I assume it's similar, runs a keyword key value. For us, the keyword is always a ledger object ID. Ledger object ID is normally the 256 SHA 256 value. In the instance data, the data is actually the instance data of the object instance. Now remember that classes and meta classes are objects too. So the instance data for the class, the instance data for the meta class are stored in here as well. We take advantage of that. As it says on the right, we manage all of the inheritance and pulling the instance data off of the blockchain at runtime at a transaction processing. Anything that's changed is automatically put back on the blockchain. If you don't make any change in instance data, then it doesn't make any update to it. And because of the automatic replication of the database, you don't need to do anything else at that point. Going down the very straight flow, transactions start, you're actually sending from a client, the account object, the target object. Again, you retrieve the ledger object IDs. I'll show you how that's done. The method name of the method you're calling on the object and the input arguments. The class manager infrastructure does first uses the object ledger object ID, the LOID key, to look up the object, it walks up the class tree to make sure that all the classes are there, pulls all of the instance data out, so you now have a running object. This all happens transparently, and the method gets dispatched to it. The method does inheritance, so that if the method is inherited from one of the ancestor classes, it will call the appropriate one, and then you can actually do ancestor calls. You can say call ancestor and walk right up the tree. Executes the code, which can include, by the way, calling any other object in your environment. that you're legally allowed to, so that the transaction can consist of multiple changes to multiple objects instance data. When the transaction completes successfully, the data is written back to the database automatically, and then you return with as long as there's no error returned, the Hyperledger Fabric will distribute it to the other nodes automatically in the standard way. So all of that happens automatically for you. Just a quick piece of that all sounds great. How do we do this? To write a class in Go, and I should make a note that theoretically you could actually write it in multiple languages, and even in your inheritance tree you could have one class implemented in one language and an ancestor class implemented in another language. We will actually build something like that at some point. We've done in the past. This was to get a proof of concept out as fast as possible. You write your implementation piece in just classname.go. These are, of course, conventional names. You don't have to do them exactly that. It's just easier when you're looking at your code. In your class implementation file, maintains data type definitions, a method table, which is used from message name to method resolution, the implementations, which are the actual code that's called to execute it, and some boilerplate that's required to load and run the class. The stub file is what's created, and you create these things yourself at the moment, although in the future we would expect to create some of this with auto code generation. The stub file is what other classes use to compile against to send messages to your two instances of your class, and the skeleton file is what's received. So the class manager infrastructure expects a stub file and a skeleton file. The class manager infrastructure will call into the skeleton file with the method to call, and the skeleton file will actually then call the correct method. You write this code by hand. At some point, like I said, we will automate it. You can see an instance of this in our open source. If I don't forget, because I'll probably forget to say it, xbom.io is our website where you can register and then go pull down the open source for this. Okay, what I'm going to do here, instead of going to this piece, again, we're trying to keep this short, is I'm going to actually bring up and do a quick example of this loading. You'll give me 1 second. I have to start up we run on a remote desktop on AWS. Hold on 1 second. Load. Look. And where's the share for this? I gotta stop sharing, start sharing, right? Yeah, here we go. Share screen and go. Okay, you should be able to see my screen. What I've done up to this point, I'm using straight, this is actually a modified test network script. So I'm actually in the test network of the Fabric samples. If you install Hyperledger Fabric, do a quick demonstration of that. The original shell script, which was here in network.sh, we've modified slightly to classmanager.sh. What we've done so far is just loaded up you can just see up here, I've just loaded up the blockchain itself. So I have 2 peer nodes in an order are running. So, and you can see this as Docker containers. There's the Dockers running. I'll come back in a second. We did not change any of the source code for Hyperledger Fabric whatsoever. What we did need to do is build our own Docker images, because the default peer nodes for Hyperledger Fabric are built with Linux images that do not enable dynamic loading of shared objects. Technically in Linux, that means that you need what's called the ld-linux.so library. And so what we did is simply change the root Linux kernel that's built into the Docker images. The reason it unfortunately makes the image larger than the very small ones that are done for Hyperledger right now, but it doesn't change any of the source code or any of the functionality of Hyperledger. So now what we're going to do is we're going to run our Bootstrap. And because we want to make the ledger object keys, which you'll see in a minute, deterministic rather than random, we have a flag, which I've highlighted, called LOID. Let me paste it over here. That gives you you can put a random value in there every time you restart the Hyperledger blockchain, so you'd always have completely unique numbers within any given chain. For test purposes, we want it to be deterministic so I can run scripts, so this forces a default value, that's all. What this is doing, here's our Bootstrap, so this is now creating all the Bootstrap classes. I have a nice, very simple return message, all objects saved. There, that means that all of the classes, which are objects that are for the Bootstrap environment, have now been stored into the blockchain so that all the nodes can use them. It means it did this standard thing, sent out all the transactions to the nodes, and that's what the piece does here, and signed them, then sent it back out. This peer capability does standard invoke. All this, by the way, we are using the as you can see, the chain code invoke command from the command line for this. So everything's standard here. Next one would be, now I'm going to actually get the root dictionary, and this is a built-in function because you need to bootstrap from somewhere. And that's what this does. And this will return the ledger object ID for my root dictionary. Ledger object ID we return as printable numbers, but this is of course a SHA 256. You could put this as hex, I could print this out in hex as well, just have it printing out as integers and expected as integers, but you could just easily change that. Now I'm going to go get the system account object, which is the object we were talking about a minute ago. In the tree I was showing earlier. You need the ledger object ID for that. So you need to go collect those two starting point ledger object IDs to do anything. I now have something that I can send a message to ask things of. And so now I'm going to send the first message. Messages are object send, and there's something also called object call, which is internal to the runtime, but object send is, you're saying send this message. Here's the, actually it's easier to see it in the black, I think. Let me bring that over there. And this is, as I said, the style of making a call. There's a couple more steps and we'll be there. I forgot you can't see the other window, sorry. So in this environment, we have class manager invoke, the arguments, here's object send. Here's the ledger object ID for the account, right here, all the way across. Here's the ledger object ID of the object we're sending the message to. Here's the a method string, the name of the method we're sending, which is class dictionary get object by name. And here's the parameter for the input arguments. We're looking for the root account manager, which is an object instance that's been created, to now be able to ask it to go make a new account for me. And so it's going to go send that message, hit return. And what it's done right here is now returned to me the object handle of the object I want, which is root account manager. So I now have an object that I can now send a message to. The message I'm going to send, I'll put that into 1 second, is to create a new account. Copy, here it comes. And what this does, so here's another message. Here's the account object. Here's the target object right here. And you'll notice that this is the same as right here, which was returned. So literally I got the object, now I'm going to send a message to it. And now what I'm asking it to do, because I know that it inherits from class factory, I'm saying make a new object. That's a message that is implemented in class factory, and so we'll inherit it. And the argument it takes is how many should I make? And of course, I only want to make one at the moment. And it is now made an object. And here's the handler returned again, ledger object ID. If you notice a little unique piece right here, there's a double bracket. This is because this would actually return an array of objects if I asked it to make multiple. So I could actually, it's a class factory, but I happen to make accounts right here. So I could say to the account manager, make me a whole bunch of accounts of this account type. And one more piece. So I now have an object, and the object is an account. It doesn't actually contain anything. It's a very short demo. But obviously I could add new objects to it. The interesting thing is, how do I know what the methods are, what the classes are an object inherits from, and what the methods are for those objects? What we added in is the ability for inspection and return back JSON schema, so you know how to send messages to it. And so the message that I want to demo for that is simply one that called, and this is implemented in the root class object, so all classes have it, all objects have it rather, class object inspect, which is going to return, looks like a very ugly piece of text, but in fact, this is, if you pretty print this, you will see that this is standard JSON schema, and that it walks up the entire class tree and gives you all of the methods in all of the arguments in JSON syntax that you can use to send to every single class that the objects inherit from. So I can interrogate any object, whether it's an object, a class, or a meta class, and retrieve this information. So it gives you a very dynamic way to manage. You could build dynamic user interfaces from it and things like that. That's as far as I want to go. Please take a look at xbom.io. When you register on that, it will give you the link to the what we call HLF XBOM public, Hyperledger Fabric XBOM public GitLab, and you can pull that down. There's a script to set up your environment in a Linux environment. We don't do Windows, and it will come up and run for you. And it's the same environment I use. Thank you very much. I do see there's a lot of questions. I'll try to pull some up and look at them. And let me stop sharing. And Mike, if you want to take over, I'll take a look at the messages.
Okay. Thank you very much, Dave, for that. I am going to share one last time. Can everybody see my screen? Slideshow.
Yes, I can.
From current. Okay. There. Can everyone see my screen?
Yes.
And hear me? Okay. Let me close that up. Okay, so the last thing that there was one question that came in I saw on is this open source? So there's two parts to this. For the developer community, absolutely 100%. This is the class code in order to build classes and offer. You can commercialize anything. Those classes, your vertical specific class trees that you make, whatever, figure those are your applications. Yes, that is open source. We don't expect any royalties, any revenue, or anything from anything you create there. What's not open source is what the CMI, the class manager infrastructure, and that will be a SaaS license to the enterprise. This is not something that we're looking for to the developers to bear any costs on. We do have a channel also set up so that there is channel opportunities in order to participate with the organization. Again, the class manager infrastructure is a monthly SaaS license to the enterprise. The class build code is fully open source with no need to add to the project. Your whatever you build is not open source. That is fully commercialized for you. Okay, so next steps. You know, we are looking for proof of concept now. We are working with a couple of different organizations here in the United States. We're looking for application and projects and you know, and the team to kind of work with, document the proof of concept objectives, and then work with us on the POC design and testing. We understand that it's a new way to look at the architecture of blockchain and such. So we're definitely here to assist in any way that we can. So as Dave said, xbom.io. You can go to xbom.io and register for access into our GitLab repository, where you can download the code and play with it. We have on xbom.io the overview page towards the bottom are 3 videos that go deep into the overview, the functional overview of XBOM on Hyperledger, goes into the concept of accounts and classes and objects, and then finally into the JSON environment that Dave built. And you know, Telegram, Prasago Official. We also have the Telegram chat, and I believe this presentation will be available after to everybody, so you can use the links there. We do have currently support for developers is through our Telegram developer channel, which is the
Hi, Michael.
non-verb one. Go ahead.
Yeah, Michael. So thank you,
Yes.
Michael. Very important question regarding the XBOM and the I think you also may be aware like DML and the kind of Accord project. So one of the person asking about how you will relate your XBOM with the digital asset and the that Accord project, because they also put some kind of abstraction at the chain code level writing.
I'm sorry, I did not hear that question. Can you ask one more, or Dave, did you?
I'm asking, there is a digital.
I guess there's some network issues at Kamlesh end. So
layer,
there is a question
like
on
you are doing
the
the
Q&A portal.
Yeah.
Yeah, there is a question on the Q&A portal which they're asking, how can we relate XBOM versus other solutions like what we see in DAML?
Dave, I'll let you answer that on the DAML question.
So I'm not sure what you're, is that DAML is what you're talking about?
Yeah, right.
Oh, okay. So the key difference for the XBOM environment for virtually anything else you've seen in any sort of smart contract or chain code or any other name for blockchain is that the class code, or in this case, actually the reference to the class code is actually stored on the blockchain. So a class exists as an object itself. And so the instance data to a class includes telling you what the methods that it'll take are, how to call the code, and in the environment with Go, it also tells you where to go find the actual plugins. But if it was in something where you're running an interpreted language, it would include the interpreted code itself. When you do an instantiate of an object, it will walk up the class tree, and those are literally looking up the blockchain for each class, which is an object for reference to another class up its inheritance tree. So you only ever, if you're adding, for example, new capability, you're adding just a subclass. You're not recompiling the entire environment to a single image. So it's a different concept from. Okay, go ahead.